The Eastern Hellbender is a giant aquatic salamander in the family Cryptobranchidae that reaches the most north of its range in New York State, whereas it is listed as a species of special concern. Following mark recapture surveys that showed population declines, the New York State Department of Environmental Conservation put forth a recovery plan. In this presentation, I will give an overview of the Buffalo Zoo's primary role of headstarting hellbenders, release techniques, survivorship, and the effects of Batrachochytrium dendrobatidis, or BD, for the headstarted hellbenders. So the Eastern Hellbender is in the family of giant salamanders, Cryptobranchidae, and averages about 2 feet in length, but can grow up to lengths of 29 inches. It likes living in cold, highly oxygenated streams and rivers, completely aquatic. It's flattened and wide in head and body with short limbs, stocky limbs. Adaptive coloration aids in its camouflage. It has mottled coloration that blends itself well into the stream bed. They like to live under large flat rocks and are mostly active at night. They're born with external gills that reabsorb at 1 to 2 years of age. They have skin folds, and those folds create more surface area for continuous respiration. You can think of them as one giant lung breathing underwater. They're a good example of a paedomorphic animal. They never fully complete metamorphism and remain in the water. They do not have eyelids, which is another paedomorphic characteristic. They have poor eyesight. They rely on a good sense of smell and their vomeron teeth to catch crayfish and other prey. They use external fertilization for reproduction, and females will lay 200 to 500 eggs, and males do provide some parental care in way of nest guarding. They are pretty long-lived species of salamander, and they can live for longer than 30 years in captivity. The hellbender ranges from New York State to Missouri and has been extirpated or is declining through most of its range. There's 2 subspecies in North America, the Eastern Hellbender and the Ozark Hellbender. Our work focused on the Eastern Hellbenders. Hellbenders face many threats beyond warming temperatures due to climate change. Human alteration of the riparian habitat leads to water siltation. This causes the large rocks that hellbenders live under to get embedded, making them useless. The hellbenders can no longer burrow or climb under those rocks. Clearing this riparian habitat also takes away shade that helps control the water from heating up. Agricultural runoff pollutes the water with pesticides and herbicides. Cow pastures running through streams increase nitrates, reducing water quality for hellbenders also. Transportation routes in New York State have redirected prime hellbender habitat in some areas through railroad construction. Also, road construction and retaining walls have disrupted natural rock generating areas, natural rock generating sites in some areas. You can see the retaining wall in that slide to the right that is a concrete structure that does not allow any rock to fall into the hellbender habitat below it. Hellbenders accidentally caught by anglers are subject to indiscriminate killing, while others purposely caught for illegal sale in the pet trade or illegal markets threaten hellbender populations. Disease such as the fungal infection, chytridomycosis, also poses risks. We do have Hellbenders testing positive for BD in New York. With all these threats that Hellbenders were facing or are facing, and market recapture surveys showing a 40% overall reduction in Western New York's Hellbender population, a call to action was made and a Hellbender recovery plan was drafted. Partners for this project included local colleges, Buffalo State and Cornell University, federal agencies, U.S. Fish and Wildlife Service, and the Department of Transportation, state agency, Department of Environmental Conservation, the Buffalo Zoo, and that eventually expanded to other zoo partners as well. The plan aimed to focus on habitat restoration, education and outreach, land protection through land purchase, and the Buffalo Zoo was contracted by the state to be the Hellbender headstarting facility. So we geared up in 2009 to collect a nest from the local stream population for the headstarting project. This is a picture of a Hellbender nest. The breeding season in Western New York starts in the fall. Males, through a courtship dance, guide females under their nest rock, which becomes the male's territory. They mate by the females releasing their eggs, kind of like in a string of pearls, it looks like. And the males releases his milk over top of the eggs to fertilize them. The male then becomes the den master and will stay with the nest, guarding it from predation and caring for the eggs. You can see the bright yellow yolk sacs of the developing larvae, and that is an indicator that the nest is fertile and healthy. So in 2009, we collected a rather large nest, and we had a great success rate of 91%. The eggs were hatched in a temperature-controlled walk-in cooler, and we kept them at local stream temperatures, varying from 11 to 5 degrees Celsius. The eggs were set up for individual care, and the larvae were moved to the lab after they were hatched. This is a fresh hatchling. They're about an inch in length when they hatch out of the egg, and they're very vulnerable. They're poor swimmers, and they are not feeding at this stage. We kept this, the vulnerable larval hatchlings in critter keepers initially. We kept them here until they were ready to feed, and the eggs hatched at a rate between 70 and 90 days from when they were laid. This is the size of a larva that was ready to eat. You can see little black worms floating in the critter keeper. That's what they initially started feeding on after their yolk sacs had absorbed. Their external gills remain, but they were a little better at swimming at this stage of life and walking on the tank floors. So that is the stage of life where we moved them into our lab. We had a lab set up of 45 30-gallon breeder tanks. And they were 4 months of age when we moved them into this lab. We had a pallet life support system hooked up to the system, and we had a bead filtration and UV sterilization. Most of the water was recirculated, but we would do back flushes on the filter and siphoning to control water quality as well. We provided PVC hides, plenty of shelter for them to get under, and air pump fed individual air stones for each tank that provided a water current and oxygen. And the Hellbenders were kept between 15 and 18 degrees Celsius. We did notice that they liked to crowd together underneath the same hide hut. Although we provided multiple places for them to hide, they definitely liked to crowd together. This is a nice picture of their toe pads also. As they grew in size, we were able to offer them different types of prey, including crayfish and redworms and earthworms, other insects. We also added a pondstone substrate to their tanks, so they weren't just living on glass. Each Hellbender was individually identified with a pit tag. And at about a year and a half, we began hard releases into back into the local streams and tributaries. So this began in 2011, and we started with 46 larvae that were about the average size of 15 centimeters. And we went with the number 46 because 4 of them actually expelled their chips. So we really wanted to be able to identify them out in the streams as released Hellbenders. So we kept those 4 back in the lab. We did another hard release in 2012, the next year after that, and they were a little larger this time at 28 centimeters. And then again in 2013, and they were still a little larger at 30 centimeters. And that brought our total of released head-started Hellbenders to 405 individuals. So after each release, the initial survey rate of monitor Hellbenders, or survival rate rather, was less than 10%. And biologists would sweep the streams in transects using a wand to locate the Hellbenders. This wand would read the pit tags that were inserted into the Hellbenders before they were released. And that's how we detected if the Hellbenders were present or absent from the tributaries where they were released into. So we wanted to take a look at why we were getting such a low survival rate. So we had a few theories. Predation. They were released at a smaller size than we were initially planning on, and that is because we were so successful with the hatch rate of the Hellbenders. We started releasing them at a smaller size than what we were anticipating initially. So predation could have been a factor. The site fidelity didn't seem to be great. Was there downstream movement of the Hellbenders? Were they just moving around, not really setting up a territory? Was the hard release itself a factor? Should we come up with some soft release techniques? And were there artifacts of captive rearing affecting their survival in the wild? So we did commonly find Hellbenders moving substantially from the initial hard release location. This is an example of one Hellbender's movement of 910 meters from the release date of July 19th in 2012, and just a few months later found it 910 meters downstream in November. So we decided to come up with some soft release techniques. And this time we surgically implanted 18 Hellbenders for radio telemetry. Julie Boner of the Buffalo State College was going to be doing the radio tracking of the animals for us, and being out there and through the telemetry, she noticed some abnormal behavior, and she started to see the Hellbenders almost gasping for air and coming up to the surface and just not really hiding or acting like you would think a Hellbender would act out there. She did recover one carcass, and that carcass did show high loads of BD. And through her telemetry, she was able to confirm 14 deaths, and 4 animals ended up missing. So that was not a very successful release at all. So again, why was it the low survival rate? How much was this BD playing a role, or how much of a factor was it? So again, in 2014, the soft release cage system was updated because the animals were coming up to the surface to gasp for air. We decided that the cages needed to remain a little bit above the water level so that they could gulp air if they needed to. You can see the size of the cages. There was an hinged door on top so that we could access the Hellbenders, but also keep them protected. The material we utilized was vinyl coated mesh with 1-inch gaps, and we used rebar to hold it in place in the stream. This is just a picture of the 2013 cage design compared to the 2014 cage design. We always made sure to put rock around the cage edges and made sure there was a larger rock within the cage also. So in 2014, there was a total of 25 cages installed in 5 different study locations. So they were quite larger at this stage, averaging 290 grams in weight and lengths of 30 centimeters. And they were 5 years old at this point. So surveys were conducted about every 2 to 4 weeks as stream conditions allowed. BD swabs were taken, the pit tag was scanned to ensure the identity of the animal, weights and total lengths were taken, gross observations, just behavioral observations, and photo IDs were taken also. So 4 to 8 weeks into 2014's release, abnormal skin coloration was noticed. The Hellbenders were starting to act lethargic out in the streams, and they had decreased in weight. So it didn't appear that they were eating. So this is just a comparative slide of healthy Hellbenders coloration as to the abnormal colorations we were seeing with the wild, or now the released Hellbenders. So, and it wasn't just one abnormal coloration. We were seeing it in many of the captive reared Hellbenders. So this is when Cornell University got involved, and we made sure to swab each Hellbender pre-release and confirmed that they were all BD negative before we put them out into the streams. And through the surveys, we found that 22 animals were BD positive. So they were definitely picking up this fungal load out in the streams. And in 2014, 19 of the 25 Hellbenders died. Only 8 of those carcasses were suitable for necropsy. They were brought to Cornell. And 7 did present with severe skin changes consistent with chytridiomycosis, which is the disease brought on by BD. There was no other evidence of any other underlying disease, so we were pretty sure that some of the mortality rates were definitely due to BD infection and chytridiomycosis. So that left us with an 18% survival rate. So other things that were included in the project was habitat restoration. The DEC, along with the Department of Transportation, purchased 14 pallets of rock and installed the rock directly into the streams to see if we could create more habitats, especially after the loss of the natural rock generating sites. Education and outreach was also a point of our focus, and the Hellbender Head Start Lab was on view to our visitors at the Buffalo Zoo, and our visitors could learn about Hellbenders and recognize that that animal did live in New York State, and we also taught them why they were important to the environment and why we were trying to make all of these efforts to participate in the Head Start project and keep the biodiversity of our streams strong in New York by protecting the Hellbender. Through a grant, we created a Hellbender mascot, and we named this mascot Sam, which stood for slimy and misunderstood. And we brought Sam to several classrooms, and it's kind of a fun way to introduce a younger audience to an animal that they may not understand or may not seem as fascinating as the other animals that live at the zoo. Our Buffalo Zoo docents also created a conservation cart inspired by the Hellbender Head Start project. We had Hellbenders living in the education department, so our visitors could get a better view of Hellbenders and get an up-close view of them and just learn more about them through our doceting. And finally, last year, New York was able to purchase the first Hellbender Preserve, and it's in Western New York. And I was named the land steward to this Hellbender Preserve. So we'll be doing things like picking up roadside trash, surveying and monitoring the Hellbender population there, amongst other things. That's exciting news.